Welcome back to the Deep Dive. If you're just joining us, we've been exploring the online encyclopedia of integer sequences. It's this incredible, huge digital library of number patterns, really a goldmine for anyone interested in math. And today, we're diving into a bit of a mathematical puzzle, you could say. How does a sequence that seems to come from simple multiplication end up hiding something like the golden ratio inside itself?
It's a great hook, isn't it?
Definitely. We're focusing on OEIS A000301. It's often called the Fibonacci Exponentiated sequence. And what makes it so interesting, I think, is that it has this dual nature. It's defined recursively and explicitly.
That's right.
Okay, so let's try to unpack that. How can one sequence have two definitions that look so different but produce the exact same numbers? And what does that tell us?
It is quite remarkable. So recursively, the definition is pretty straightforward.
Yeah.
AN equals AN1 times AN2.
Okay, so you just multiply the previous two terms.
Exactly. You start with initial values, A0 equals 1 and A1 equals 2. Then the next term is 1 times 2, which is 2. Then 2 times 2 is 4. Then 2 times 4 is 8.
Right. 4 times 8 is 32. 8 times 32 is 256.
Oh,
Okay, I see. They get big fast.
very fast. But then there's the explicit definition, which is simply 2 raised to the power of the nth Fibonacci number. So 2 Fibonaccian.
Okay, 2 to the power of fn, and that gives the same sequence. 1, 2, 2, 4, 8, 3, 2, 256.
The exact same sequence. It's a perfect match.
That alignment is, well, it's striking. Is that sort of thing common with important sequences, or is A000001 special in this way?
That's a really good question. I mean, some sequences do have multiple definitions, sure, but let's say the elegance and the perfect alignment we see here, it often signals something deeper, a kind of inherent structure.
Like the definitions are two sides of the same coin.
Exactly. Each one reveals something different about the sequence's properties. And this kind of harmony often hints at connections to other fundamental mathematical ideas or constants.
And that's where it gets really exciting for me with A000301. It connects to some really big constants, doesn't it? It's not just living in isolation. I heard something about the golden ratio.
Oh, absolutely. It's far from isolated. The really compelling part is how A000301 appears in the continued fraction expansion of another constant, which is listed in the OEIS as A073115.
Okay, continued fractions. Remind us quickly.
Sure. A continued fraction is just a way to write a number as a sum of an integer and a fraction, where the denominator is again an integer plus a fraction and so on. It can go on forever, like a nested fraction.
Right, an infinite staircase of fractions, kind of.
Sort of, yeah. And they can reveal amazing patterns in numbers. So this constant, A073115, is roughly 1.7098.
Its definition actually involves powers of 2 and the golden ratio phi.
5, which is about 1.618.
That's the one. Now, the amazing thing is the continued fraction for A000311 starts 1, 1, 2, 2, 4, 8, 32.
Wait, 1, 2, 2, 4, 8, 3, 2. Those are the terms of A000301 after the initial 1, precisely. The terms of our sequence literally form the coefficients in the continued fraction of a constant that's intrinsically linked to the golden ratio.
So it's not just a coincidence. It's like embedded in the structure. What does that reveal about, I don't know, the nature of numbers?
Well, I think it's a beautiful demonstration of how interconnected things are. You know, how these discrete integer sequences can echo within continuous, sometimes transcendental numbers. It hints at a deeper harmony.
Wow.
And there's more, actually. There's something called the rabbit constant. It's related to A007315. It's just that constant minus 1. Its continued fraction starts 0, 1, 2, 2, 4, 8. Again, there's A000301.
And rabbit constant because of the Fibonacci link, like the rabbit breeding problem.
Exactly that. It's named for that direct link to Fibonacci numbers.
That's fascinating. So we have this elegant sequence, two simple definitions, and then boom, it shows up structuring constants tied to phi and Fibonacci growth. It really underlines how interconnected math is.
It does. What A00030301 illustrates so nicely, I think, is that even simple integer patterns, defined in straightforward ways, can have these profound resonances in the continuous world of real numbers. Their properties aren't isolated.
They're woven together.
Deeply interwoven, yes. Often waiting for us to spot the connections.
What a fantastic deep dive into A000301. From those twin definitions to its really unexpected appearances linked to the golden ratio and continued fractions. It's just a beautiful piece of mathematical harmony.
And maybe this leaves you with a question to think about. When you encounter a new sequence, maybe one that looks simple on the surface, how might its properties be hinting at much deeper connections? these hidden mathematical truths just waiting to be uncovered.
That's a great thought to end on. Thank you for diving deep with us today. Keep exploring, keep asking questions, and definitely continue your own deep dives into this amazing world of numbers.